This is the second video on graphing exponential functions. In the previous video, we looked at anything in the form of f of x equals a to the x. It's going to have this kind of curve to it. Now, how steep it is and where it goes through the axis depends on the whole function, but this is your basic 2 to the x. Now, how we know this is 2 to the x, if we looked at a basic chart, 2 to the 0th is 1, 2 to the 1 is 2, 2 squared is up here at 4. 2 to the negative 1 is a half. That's why the chart looks like this. So if you begin with 2 to the x, which is this along the green, then this is all we have to look at. There has been a certain transformation here. Because this says x minus 2 and this entire thing is up at the exponent, we know that this whole graph needs to move to the right 2. So I'm going to take individual points and move them to the right 2. Take this point, count over 1, 2, and put a dot. Take this point, count over 2, and put a dot. Maybe this one right here over 1, 2. And you see it's going to look like this same kind of parallel curve. Now, to make this a little neater, I'm just going to grab a hold of this and move the whole thing over 1, 2. And you can see that looks pretty good. Now, you don't have that capability on your paper, but on your paper you can put these dots and then draw in this curve. I just have a hard time drawing that curve, so for me it's just easier to do the whole thing and line up my curve with those red dots. So that is the graph of f of x equals 2 to the x minus 2. Let's put two of the changes together. We had a horizontal shift and a vertical shift that we looked at in the last video. Now let's look at this right here. This is our basic 2 to the x. These are my chart numbers just to remind you where this comes from again. 2 to the negative 1 is a half. 2 to the 0 is 1, 2 to the 1 is 2, and 2 squared is 4. That's my basic t-chart for y equals 2 to the x. This function right here tells me two things. It tells me this needs to go to the left 1, and this right here tells me it needs to go down 2. So each point is going to move that way, to the left 1 and down 1, 2, to the left 1, down 2, to the left 1, down 2, and you can see this curve would look something like this. Keep in mind we do have a horizontal asymptote right here because this has shifted down 2, so that horizontal asymptote is going to kind of lock me in to the curve coming up like this, and then it gets kind of weird for me with the tool, something like this. This is the graph of f of x equals negative 3 to the x. Now I've already graphed it for you, but let me show you where these points came from. I've chosen my usual negative 1, 0, 1, 2 for the x value, and I've written this out for you just to save time. So this is negative 3 to the negative 1. Remember, the negative exponent creates a fraction, so this is 1 over negative 3, which is the same as negative 1/3. If we put 0 in here, it's just 3 to the 0th, which gives me 1, but there's still a negative in front of there, so it's negative 1. This is easy. 3 to the 1 is just 3 with a negative, and this is also just 3 squared, which is 9, but with a negative in front. So the rest of my chart looks like this. And this is where this curve came from. Negative 1 down 1/3, 0 down 1, over 1 down 3. I couldn't fit the 2 negative 9, but it's in the same line over here. Drop it down here somewhere, and there's my curve running along the axis, shooting on down to the bottom. Just to show you, this was the original f of x equals 3 to the x. This is negative 3 to the x. Notice this curve right here has been reflected or flipped over the x-axis. So the negative in front of the base reflects or flips the graph over the x-axis. It is also possible that your exponent is negative. So here was our regular 3 to the x, that's this one, and the 3 to the negative x gets graphed this way. Now, where did these graphs come from? I used a graphing utility. I just did this to show you the relationship here. Now, what has happened with this curve? It has been flipped over the y-axis. The negative in front of the exponent flips the graph over the y-axis. Here's a little summary of the last two transformations. If you have f of x equals a to the x, then our new function with a negative a to the x, this is going to flip this over the x-axis. If the negative is here, it goes over the x-axis. If the negative is up here with the exponent, it goes over the y-axis. So you do need to memorize that. Or you could always make a t-chart and look at your arithmetic, but this is easier to memorize. Let's put a couple things together here. I've already done the chart of your basic 2 to the x. This is not this chart. This is basic 2 to the x. And I have graphed this, and here are 3 points that came from my chart. I need to do these transformations. Right here it tells me that this needs to flip over the y-axis because the negative is up with the exponent. Then I need to move it up 3, and it needs to be in that order. Flipping over the y-axis happens before up 3. This is an order of operations thing. Flipping over the y-axis is like multiplying by -1. Multiplication happens before addition. So I'm going to take each of these points and just flip them over the y-axis. I'm just doing one thing at a time. So flip this over the y-axis, goes here. This is already on the y-axis. It's going to stay here. This is going to flip over here. So 2 to the negative x would just be this curve that I'm tracing out. But I need to move that up 3. So let's change colors to this and take each of those points and move them up 3. 1, 2, 3. This point up 1, 2, 3. And this point up 1, 2, 3. And you can see my curve coming through this way. Here's a conclusion of all of the different transformations we have done on both of these videos. If we start with a basic a to the x, a to the negative x flips over the y-axis. Negative a to the x flips over the x-axis. Those are easily confused. You need to memorize that. A to the x plus b, as long as this number is after the plus or minus here, it is a vertical shift. Move it up b units. Same idea here, but because of the minus, we move it down b units. These two, the c, the transformation is up here with the exponent, which makes it a horizontal shift. This moves left c units. It goes opposite of the sign. This one, because this says minus c, goes opposite the sign, which means we need to move it to the right c units. You may have heard of e. E is called the natural base. This is an irrational number because this keeps on going. It is an irrational number like pi. It doesn't repeat, it doesn't terminate. We generally use like about 2.718 as e, but it does continue indefinitely. Where e comes from is evaluating this expression right here as n gets larger and larger and larger. So you could take your calculator and type this in, or you could just look at this chart. If n is 1, this works out to be 2. If n is 2, it works out to be 2.25, etc. All the way up to 10,000. If n is 10,000, this is 2.71814, etc. Notice how close we're getting to this 2.71828. You could extend this chart out to 100,000, to 1,000,000, as long as your calculator would do the arithmetic. But that's where e comes from. It is an irrational number. It is used in a whole lot of word problems that you're going to see in the rest of this chapter. The graphs that we did with a to the x are going to look the same with e to the x. So f of x equals e to the x is called the natural exponential function. Now because e equals 2.718, this is the same as saying f of x equals 2.718 to the x. This graph is going to look like 2 to the x or 3 to the x. It's just that this is a decimal. Here is a nice neat graph of e to the x, and you should realize, oh, it looks just like those other graphs we did. Here's just the numbers in the chart. I used the calculator to get these. E to the -1 is 0.367. I used a calculator. E to the 0th is 1, because anything to the 0th power is 1. E to the 1st is approximately 2.7. And e to the 2nd is about 7.4, which goes off the graph. If we want to look at either one of these things, it's the same rules we established. E to the x plus 1 means each of these needs to be moved up 1. Take this point, go up 1. Take this point right here, go up 1. Take this, go up 1. And you see the curve that we're getting. We will have a horizontal asymptote at 1. Same rules before, because it's shifted up 1. The horizontal asymptote becomes that red line. So this is e to the x plus 1. If I want to do e to the x minus 2, all I have to do is take each of these points and drop them down 2. Drop this down 2. Take this one down 2. And you see the curve that we're getting is about like this. So it's the same rules that we established for a to the x, 2 to the x, 3 to the x is going to work the same for e to the x. F of x equals e to the negative x. Same rule. What the negative does is takes this thing and flips it across the y-axis. So this point is going to flip over here. This point that's on the y-axis stays. This one flips over here, and you can see that e to the negative x looks like this. E to the x plus 1, this is up with the exponent, so this is going to have to go to the left 1. So take each of these points that you see and move them to the left 1. And it's going to look something like this.